In this lecture, I'll explain you about persistent queues, and then we'll see some questions on persistent queues. Okay, so as we know, suppose if we are having a local, suppose if you are having a Mule application which is using VM queues. Whenever we are using a VM connector, it will publish the messages into a VM queue. And this queue can be either transient or persistent. Suppose if I configure this VM queue as transient, whatever we are sending to this queue will be in memory. So if the application crashes, the data also will be lost. But if I make it as persistent, then the data whatever we are pushing into queue will be saved. But where? Suppose if I'm deploying my application onto standalone runtime, if my application is deployed to standalone runtime, it writes the data whatever we are writing into VMQ in local file system on the machine. But if you are deploying your application to Cloud Hub, on Cloud Hub, as you know, a separate VM will be created for your application, and inside that VM the application is running. So if you have made the VM queues as persistent, then suppose if this application is writing the data to local file system, whatever data is written to VM queue, if it is writing to local file system, if the VM crashes and it gets restarted, the data will be lost. The data in the VM queue will be lost. So we know that if we are deploying our application to Cloud Hub, and if we have persistent queues enabled, then this local queue, whatever we are writing to local queue, they will be written to Amazon SQS. This we know. In Amazon, there is a service, simple queuing service. The VMQ will be backed up by this one. So there is some network delay. Whenever we write a message to VMQ, it has to be sent to Amazon SQS. Remember that there will be a network delay. And also, whenever you are deploying your application to Cloud Hub through Runtime Manager, there is an option to enable persistent queues. Let me show you. Here I am in Runtime Manager. If I try to deploy an application and if I select Cloud Hub, you can see there is an option persistent queues I can enable, and encrypt persistent queues also I can enable. So in your application, if you have configured a persistent queue and if you enable this persistent queue, then whatever you are writing to VMQ will be backed up by Amazon SQS. But there are some advantages and disadvantages of persistent queues on Cloud Hub. There are some articles which I'll point you uh, to understand more about persistent queues. So I'll just go through this article because there are some questions which are possible on persistent queues. So you need to have a good understanding. So this is a URL uh, from help.mulesoft.com. They have published this article. So Cloud Hub persistent queues is a cloud service that allows messages that are published to VM queues to be stored externally to the application. This feature is directly tied into Cloud Hub Fabric feature and is part of Cloud Hub's high availability infrastructure. When Cloud Hub persistent queues is enabled, it allows developer to design VM queues in such a way that payload can be shared across different workers for the purpose of load distribution. So what they are saying is, suppose if you are having a cluster of your application, if you configured workers in a cluster, and in your application, if you are writing to VM queues and reading from VM queues, one flow might be pushing the messages to VM queue, and in this application another flow might be listening for messages inside this VM queue. So if you are running in a cluster, the same application will be running on other node also, where there will be a listener listening for this queue. So whatever messages are going into this queue, they can be consumed by message listener on this node and this node. So the messages are distributed across the nodes in a cluster, and load is balanced, right? And of course, if this VM queue is persistent, then this VM queue is backed up by Amazon SQS. So whatever messages we are sending to VM queue, they will be actually persisted in SQS also. So that in case any worker crashes, no problem. The other worker is still running. It will process the messages from here. We will not lose the messages. And once another worker starts, it will again take the load, right? So we will never lose our messages. Even if two workers in the cluster crash also, the data is still there in the Amazon SQS. Once you restart your cluster, the data will be processed. We will not lose any messages. So when Cloud Hub persistent queues are enabled, it allows the developer to design VM queues in such a way that payload can be shared across different workers for purpose of load balancing, load distribution. In the case of failure of one of the workers in multi-worker deployment, messages on the queue are able to be consumed by other working workers, ensuring continuity. That is the purpose. How to enable persistent queues? As I told you, in runtime manager, you can select persistent queues. Okay. The options found in runtime manager application settings page. Okay. And let us see the use cases for Cloud Hub persistent queues. Cloud Hub persistent queues is a specific feature for a specific task. Its design is solely to enable capability to share payloads across multi-worker application deployments. That is the sole purpose, to be able to share the VM queues, to be able to share the VM queues. If you are deploying to multi-worker, if your application is deployed to multiple workers, the main purpose of persistent queues is to share the load. Okay. It should only be used for this purpose. Enabled for this purpose, Cloud Hub persistent queues will improve high availability, resiliency, and performance due to load distribution. What are the use cases not suited? This is very important to understand. Reliability patterns. So when implementing the reliability pattern, I hope you remember in my course I told you the persistent queues are used, VM queues are used. VM queues are used in reliability pattern. So cloud of persistent queues should not be confused with traditional Mule VM queues. While Mule persistent VM queues are intended to be part of reliability pattern solution, This was never the intention of Cloud Hub persistent queues. The strong recommendation is that Cloud Hub persistent queues should not be considered as a feature when designing reliability pattern. Okay. With that said, Cloud Hub persistent queues should never be enabled for single worker applications. For a true reliability pattern, you can use any of the brokers. And if it comes to performance limitations, applications with Cloud Hub persistent queues will process messages up to 10x slower than not using Cloud Hub persistent queues. Oh, if you are using Cloud Hub persistent queues, your application will become 10x slower. The performance is further significantly decreased if encryption option is used. The reason for this is because Cloud Hub persistent queues uses network attached storage, which is both network latency and physical limitations. Okay. When persistent queues checkbox is unticked, the VM queues will be stored either in memory or local file system based on VM setting. And batch job will use local file system based persistent queues on a worker. And one more thing here, one time only message delivery cannot be guaranteed with Cloud Hub persistent queues. Duplicate messages can be sent. So if your solution requires strict one-time delivery, do not use Cloud Hub persistent queues. And this Cloud Hub persistent queues will retain the messages only for 4 days. Don't use it for long-term storage. Then especially listen carefully about batch jobs. Mule batch jobs internally make use of queues. As we know, in batch, there are 3 phases. Load and dispatch phase of the batch will push all the records to a record queue. And record queue is a persistent queue. Right. So Mule batch uses queues. When persistent Cloud Hub persistent queues is enabled for an application with batch processors, severe performance degradation will occur. Keep this in mind. Batch also has its own set of limitation incurred if using Cloud Hub persistent queues. The significant one being that message reliability is not guaranteed. Message loss can still occur in case of application restarts. This limitation means there is no benefit from having Cloud Hub persistent queues enabled for batch application. So Cloud Hub persistent queues should not be enabled if the application has batch processors. Keep this in mind. So this is the documentation, and there is one more document related to batch jobs. Uh, Another document, this is the URL. Okay. If reliability of Cloud Hub persistent queues in regards to batch operations. Actually, Mulesoft recommends that applications containing batch component do not use Cloud Hub persistent queues. Reliability of Cloud Hub persistent queues. Let us see. If a runtime or application running batch fails or restarted, the message loss can still occur in batch if you are using persistent queues. Cloud Hub persistent queues in use case of batch cannot guarantee no message loss. Because of this limitation and because of persistent queues have potential listed down known issues and will incur performance impact, do not enable persistent queues for batch application. What is the advantage of running batch without Cloud Hub persistent queues? Your batch process can execute up to more than 10x faster. Keep this in mind. How to use Cloud Hub persistent queues for an application that contains VM queues and is a Cloud Hub Fabric multi-worker deployment and uses batch? So, what you can do for this specific scenario, it is still possible to enable Cloud persistent queues for usage by normal VM, but disable Cloud Hub persistent queues only for batch. How? By setting this property batch.persistent.queue persistent.queue.disable equals to true. So I want you to understand these all points about persistent queues related to VM queues and also batch. There will be some questions on certification. Let me show you an example of a certification question. Um, Let us see this. This is sixth question. A Mule application is required to periodically process large data set from backend database to Salesforce CRM using batch job and configured properly to process high rate of records. The application is deployed to two Cloud Hub workers and no persistent queue is enabled. Okay, so let me explain. So there is an application which will read from database and write to Salesforce. And this application is internally using a batch job in a flow. And they have disabled persistent queues. What is a correspondence if worker crashes during record processing? Okay, remember, let's assume that you are running a application in a multi-worker deployment. So your application will be deployed onto multiple workers. Assume that this is worker 1 on Cloud Hub and this is worker 2 on Cloud Hub and application is deployed on a cluster. Sorry, not a cluster, multi-worker. Same application is deployed. And if um, that job is running now on this worker, it will have a record queue, right? That record queue will be written into this app. On this machine, it will be written onto local file system. Okay. The batch job will write the record queue. Whatever records we are writing to record queue in a batch job will be written to local file system. And if the batch job gets triggered on worker 1, batch job will execute only on worker 1. The load will not be distributed, right? So remember one important thing, batch job, if it starts on one worker, the entire batch will run on one worker only. Maybe another batch job, a new batch job instance may start on worker 2. But one batch job entirely runs on one worker. And these records are written to local file. Now the question is, if the worker crashes during record processing, the VM crashes, these records are also lost, right? So what remaining workers will be processed by second worker? No, the second worker does not know about this queue, local queue, which are the queue which is written to local file system. No, remaining records will be processed by a new replacement worker. Suppose if this worker crashes, another worker will be automatically started by Cloud Hub. So will it process? No. The records are written to local file system. They are already lost. All records will be processed from scratch by second worker, leading to duplicate processing. I don't think so, because here in this application they are reading from database and writing to Salesforce. So once the data has been read from the database, the records are fetched. Again, on second worker, why will it fetch, or why will the flow gets triggered again if worker 1 has already fetched? No. So all records will be processed from scratch by second worker? No. So my option is the remaining records will be left unprocessed. This is what I feel is a correct answer. Okay, that's it.